All right, everyone, welcome back. This is day one of our last unit, Unit 9, and this is on systems of linear inequalities. And let's just remind ourselves of how we would graph a linear inequality. You would first replace the inequality sign with an equal sign, and then you would sketch the graph of the resulting equation, which would be a line. All right, you'd use a dashed line if it is less than or greater than. You'd use a solid line if it's less than or equal to or greater than or equal to. Then you'll test one point in each of the regions formed by the graph in step 1. If the point satisfies the inequality, then you shade the entire region to denote that every point in the region satisfies the inequality. All right. So let's put this into action. In example 1, they want us to sketch the graph of y is greater than -2. We'll do that on the first graph. And then also graph y is less than or equal to 3. We'll do that on the second graph here. All right, so first let's do the y is greater than -2. So if we follow the steps, we would change the greater than symbol to an equal sign. So we would write y is equal to -2. Now we will graph that line. Now we all know that this is going to be a horizontal line passing through -2. And that horizontal line should be a dashed line. And that is because in the directions it says we want a dashed line if it is less than or greater than. All right, and the original problem had greater than, so we have a dashed line. And then we choose a point on either side of the line and test it. Well, this is very simple. It says y is greater than -2. So that means we need a point that is above this line, because any point above this line will have a y value greater than -2. So we end up shading everything that is above this line. So everything above this line gets shaded, and that represents the fact that any point in this shaded region would satisfy this equation or this inequality. All right, part B, we're graphing y is less than or equal to 3. So the first step would be to change the inequality to an equal sign, and then we're going to graph the equation y is equal to 3. That's going to be a horizontal line passing through +3. And that line should be solid because the original inequality included the less than or equal to. All right, now we pick a point on either side of the line that would satisfy this inequality. Well, since it says y is less than or equal to 3, it has to be any point that is below this line. So any point below this line would satisfy the inequality that y is less than or equal to 3, and therefore we end up shading everything below the line. Okay, and here is example number 2. Sketch the graph of x minus y is less than 2. Well, the first step would be to change the inequality to an equal sign. And then we're just going to rearrange it to get y by itself, to get it in slope-intercept form. So the second step would be to move the x over to the right side by subtraction. So we have -y is -x plus 2. Then we need to get rid of the negative, so we'll divide by -1 everywhere. And we get y is x minus 2. Now we can go ahead and graph this line. Okay, so let's graph this. Now we know that the y-intercept is -2 and the slope is +1. So this would be the graph here, right? Crossing the y-axis at -2, and the slope is up 1 and over 1, up 1 and over 1, etc. Now the line should be dashed like we have it because the inequality is less than without the equal. All right, and then in the instructions it says we need to choose a point on either side of the line. whenever you can plug in 0, 0 for your point, that's the easiest point to choose because of the easy calculation. So let's use 0, 0. And if x is 0 and y is 0, you're going to get 0 minus 0, which is 0. And 0 is less than 2. So that is a true statement. So that means 0, 0 is a solution. And therefore, any point on that same side of the line is also a solution. So we can end up shading this entire side of the line. All right, and that is our solution. All right, now we're going to get into systems of inequalities. Many practical problems in business, science, and engineering involve systems of linear inequalities. An example of such system is below. So in a system of inequalities, you have two or more inequalities given at the same time. So we have x plus y is less than or equal to 12. That would be this line right here. Okay, that's the line x plus y is less than or equal to 12, or equals 12. We have another line, 3x minus 4y is less than or equal to 15. The line representing that would be this line here. We have the line x is greater than or equal to 0. That's going to be a vertical line, and that would be right at the y-axis. And then we have y is greater than or equal to 0. Well, y equals 0 is a horizontal line, which is the x-axis. All right, and then the shaded area is the area that satisfies all four of these inequalities at the same time. So it would be underneath the first line, it would be above the second line, it would also be above the x-axis here, and it would be to the right of the y-axis. So all of this blue shaded area would represent the solution. And this point 2 comma 4, this point 2 comma 4 would satisfy all four of those inequalities at the same time. Okay, in example 3, it says sketch the graph and label the vertices of the solution set of the system shown below. All right, so in this first inequality, x minus y is less than 2. We want to rearrange this to get the y by itself. And I'm actually going to just leave the inequality symbol there. I'm not going to change it to equal. And you'll see how that can be helpful here in a second. So I'm just going to leave the inequality. All right, so the first thing we need to do is move the x over to the right by subtraction. So that would be negative y is less than negative x plus 2. Now we're going to get rid of the negative by dividing both sides by negative 1. And that's going to be y is greater than positive x minus 2. So all the signs change. But also, because it's an inequality, the relationship of the inequality reverses. So when it was less than here, it reverses to be greater than here. So we have the equation, or the inequality, y is greater than x minus 2. Now the reason why that's helpful is because if y is greater, that means it is going to be above the line. So when we graph it, we're going to make sure that we shade above the line. All right, let's go ahead and graph that. Now you remember we graphed this equation before. It has a y-intercept of negative 2 and a slope of 1. So here we are crossing at negative 2 and then going up 1 and over 1, up 1 and over 1. It is a dashed line because it is greater without the equal. And because it is greater, we know that we're going to be shading above this line. All right, let's go to the second inequality. We have x is greater than negative 2. If x is greater than negative 2, first, we recognize that if x is equal to negative 2, it's a vertical line. So what does it mean for x to be greater than negative 2? It means that it would be everything to the right of that vertical line. So anything to the right of the vertical at negative 2 will be greater than negative 2. So let's go ahead and graph that line. It's going to be a vertical line going through negative 2, and we're going to be shading to the right of this vertical line. All right, let's go to the third inequality. That's y is less than or equal to 3. Well, suppose that we change the less than or equal to equals. If y is equal to 3, that's going to be a horizontal line. And because y is less than or equal to 3, that means we're going to be shading below. So it's going to be a horizontal line, and we're going to be shading below this horizontal line. So graphing that, horizontal line at 3, and we're shading below it. So now you can see exactly what region we should be shading. We're shading below the red line, above the blue line, and to the right of the green line. So that is shading this triangular space in here. Now we can double check that by choosing the point 0, 0, which is in this region. So we select 0, 0, and let's make sure that it satisfies all three original inequalities. Well, if x is 0 and y is 0, then we have 0 minus 0 is 0, which is less than 2, and that is true. At 0, 0, x would be 0, and 0 is greater than negative 2, so that's also true. And if y is 0, 0 would be less than or equal to 3. That's a true statement. So all three inequalities are true if we choose 0, 0. So that emphasizes the fact that our solution space is inside this triangular area. So let's go ahead and shade that, and that is our triangular area. Now the last thing it's asking is to label the vertices, and we just label the vertices by choosing these points at each corner. All right, so this first vertex over here is at negative 2, 3. So negative 2, 3 is one of the vertices. This point over here is over 5 and up 3. So that's another vertex. And this vertex here is negative 2, and then down 4. So negative 2, negative 4. All right, and those are our three vertices, or our three corners of the shaded region. All right, one more thing of note is to be aware that a system of inequalities will have no solutions if there are no overlapping areas. So if you have, for instance, a inequality where you're shading above the red line and below the blue line, and maybe to the left of the green line, then none of those regions overlap. They don't come together. So in that situation, there would be no solution. All right, let's get into some of the homework questions from this worksheet. Now it says to complete every third problem. So starting with number 1, the next problem you do is 4, and then 7, and then 10, etc. All right, let's go down here to number 7. We want to sketch the graph of the linear inequality. So we have number 7, x is greater than or equal to 2. All right, so let's scroll down to some graphs here. So we're graphing number 7, and that is x is greater than or equal to 2. We know this is going to be a vertical line. It's going to be a vertical line going through 2. So let's go ahead and draw that vertical line. Actually, this is going to be solid. All right, solid instead of dashed. And the reason it is solid is because this is greater than with the equals. All right, so if it has the equals, it's going to be a solid line. Now, because it's vertical and x has to be greater than 2, that means it would be everything to the right of that. So you'll just end up shading everything to the right of this vertical line. So all of this space here. All right, now let's go to the next question, which would be number 10. Let's go over here. All right, so for number 10, let's see. It is y is less than or equal to 7. All right, so y is less than or equal to 7. Now we know if y is equal to 7, that would be a horizontal line. So here we're at 5. We just need to maybe extend it just a bit. So up here, go all the way up here to 7, and you have this horizontal line. Okay, so that's the line y equals 7. Now, if it says y is less than or equal to 7, that means it has to be everything below 7. So we're going to end up shading everything below this line. So all of this space is our solution. All right, let's do the next one, number 13. All right, what is number 13? Number 13, we have 2y minus x is greater than or equal to 4. Okay, so 2y minus x is greater than or equal to 4. What we want to do is get the y by itself so we can write it in slope-intercept form. So the next step would be to move the x over to the right side by addition. So that would give us 2y is greater than or equal to x plus 4. Then we'll need to divide by 2 everywhere. So that would be y is greater than or equal to 1/2 times x plus 2. So this is the inequality we're looking at. And to graph this line, it has a y-intercept of 2. And it has a slope of 1/2. So that means we'll go up 1 and over 2, up 1 and over 2. And then we can go backwards, so down 1 and to the left 2, down 1 and to the left 2, and so on. All right, now this line that we're drawing is going to be solid because it is greater with the equal. So we're just going to draw a solid line through all of these points. All right, there's our line. All right, now because it says y is greater, we're going to be shading above this line. All right, so our shaded area is above the line, so it is all of this space. All right, that is number 13. All right, now let's jump over to number 28. It says, in exercises 27 to 30, determine whether each ordered pair is a solution of the system. All right, so first let's start with point A. That's 0, 2. So we're plugging in 0 for x and 2 for y. Negative 2 times 0 is 0. And 5 times 2 is 10. And 0 plus 10 is 10, which is greater than or equal to 3. So that works. And then y is 2. 2 is less than 4. That works. And then negative 4 times 0 is 0. Negative 2 times 2 is negative 4. So that's 0 minus 4 is negative 4, which is less than 7. So that works. So 0, 2 is a solution. Yes. All right, let's go to the next point. Negative 6, 4. All right, so let's plug in negative 6 for x. So that makes that 12. Plugging in 4 for y makes that 20. And 12 plus 20 is 32, which is greater than 3. That's yes. If we plug in 2 for the y, plugging in 4 for y, 4 is not less than 4. So that does not work. Therefore, we can stop and say that this is a no for that point because it does not satisfy the second inequality. All right, now let's try the third point, point C. So x is going to be negative 8, y is going to be negative 2. Negative 2 times negative 8 is positive 16. 5 times negative 2 is negative 10. And 16 minus 10 is 6, which is greater than or equal to 3, so that's a yes. For the y is negative 2, and that is less than 4, so that's a yes. And negative 4 times negative 8 is positive 32. Negative 2 times negative 2 is positive 4. 32 plus 4 is not less than 7. So we can stop there and say that that is no for the third point. Now we go to the fourth point. All right, so that means that we're plugging in negative 3 for x and 2 for y. So that's negative 2 times negative 3 is going to be positive 6. And 5 times 2 is 10. 6 plus 10 is going to be greater than or equal to 3. So it works for that one. The y is 2. And 2 is less than 4, so it's a yes for that one. And negative 4 times negative 3 is positive 12. Negative 2 times 2 is 4. And 12 minus 4 is 8, which is not less than 7. So it does not work for the third one, and therefore this would be a no. All right, so the only yes was point A. All right, let's do number 31. It says sketch the graph of the solution of the system of linear inequalities. So for 31, we have x is greater than or equal to 0, y is greater than or equal to 0, x is less than or equal to 2, and y is less than or equal to 4. All right, so we need to go down to one of these graphs, and we'll copy and paste that. Okay, all right, so here again, x is greater than or equal to 0. Well, if we just say x is equal to 0, we know that's going to be a vertical line going through 0. And it's going to be solid because it includes the equals. All right, so we're drawing a vertical line through 0. All right, and it says x is greater, so that means we're going to be shading to the right of that line. All right, so that's my little arrow there to remind me about that, shading to the right. The next inequality says y is greater than or equal to 0. Now, y equals 0 is a horizontal line going through 0. So let's draw a horizontal line going through 0. And again, this is going to be solid because it includes the equal. And now it says y is greater than 0. So that's going to be shading above that line. All right, now here we have x is less than or equal to 2. All right, x is less than or equal to 2. So if x is equal to 2, it's going to be a vertical line. So let's draw a vertical line at 2. And again, it's solid. All right, and since it says x is less than that, then that means we have to shade to the left of that one. Okay. All right. So then we have this next one that says y is less than or equal to 4. So y equals 4 is a horizontal line going through 4. So let's draw a horizontal line going through 4. It should be up here. Again, it's a solid line again. And it says y is less than the 4, so that means we're going to be shading under it or below it. All right, so it looks like we've established where the solution area is. It's got to be under this green line. It's got to be to the left of the yellow. It has to be to the right of the purple. And it has to be above the blue. So it looks like our shaded area is going to be right in this space. All right, so that is it. This is our solution area. Okay, so after 31, the next one you'd have to do would be 34. So make sure you do that one. I'll let you guys do that. I'll skip it for now. Then after that, you'd have to do 37. Let's do 37 together. All right, so I'm going to grab that, and let's do 37. All right. Okay, so for 37, you're going to need to graph these three lines and then do the shading. But it'll be easier to graph if we convert each of these into the slope-intercept form. All right, so let's do that. Let's take this first equation. So we have negative 3x plus 2y is less than 6. We're going to move the 3x over to the right by adding. So 2y equals 3x plus 6. And now we're going to divide everything by 2. So y will be less than 3 over 2 times x plus 3. All right, let's go ahead and graph this. This is going to have a y-intercept at 3. And then my slope is 3 over 2. So I'm going to be going up 3 and then over 2. All right, so that's my next point up here. Now I'm going to go backwards. So I'm going to go down 3, 1, 2, 3, and then to the left 2. So that'll be a point right there. And then just repeat that down 3 again and to the left 2 again. All right, so I've got these 4 points that I can draw a line through. Now, is this going to be dashed or is it going to be solid? Well, it's y is less than without the equal, so it's just going to be a dashed line. So let's do that. Draw a dashed line here. All right, through those points. All right, and then because y is less, we're going to be shading below that. So I'm just going to draw some arrows going downward from that line as a reminder. Okay, great. Let's go to the next equation. We'll use a different color here. So the next equation is x plus 4y is greater than negative 2. All right, want to get the y by itself, so we'll move the x over. So 4y is greater than negative x minus 2. Now let's divide everything by 4. So y is going to be greater than negative 1/4 times x minus 2 over 4, which would reduce to negative 1/2. Okay, all right, so let's graph that. My y-intercept is going to be negative 1/2. So negative 1/2 is here. All right, that's negative 1/2. And then my slope is down 1 and over 4. Down 1 over 4. So let's go down 1 and over 4. 1, 2, 3, 4. Okay, and then let's go back the other way. So let's go up 1 and to the left 4. 1, 2, 3, 4. All right, so we've established these 3 points right here. 1, 2, 3, and let's go ahead and draw the line between those points. Now it says y is greater without the equal, so it's going to be a dashed line. Okay, there we go. All right, now are we shading above or below this purple line? Well, it says y is greater. So if y is greater, we're going to be shading above. So let's just draw some lines going above this line. Okay, so far we're shading below this green and we're shading above this purple. All right, now let's go to this third inequality and change colors. All right, so it's 2x plus y is less than 3. 2x plus y is less than 3. All right, we just need to move the 2x over by subtraction. So y is less than negative 2x plus 3. All right, my y-intercept is going to be at 3. And then my slope is negative 2, which of course is the same thing as negative 2 over 1. All right, so we'll start at 3 as our y-intercept, which is right here. And then the slope is negative 2 over 1, so we're going to go down 2 and over 1. So that'll be another point there. And let's go down 2 and over 1 again. Be there. Down 2 and over 1 again. and down 2 and over 1 again. All right, and then we can go up 2 and to the left 1, so we'd have a point up here. All right, connecting all of those points. And again, this is going to be a dashed line because there's no equal. All right, so let's go ahead and draw the dashed line. All right, and then because it says y is less, that means we're going to be shading below this blue line. So shading below this blue line. All right, so now I think you can see where the solution area is. It's got to be below the green, above the purple, and below the blue. So it looks like it's going to be in this, merging in this triangular area here. All right, so I'll just go ahead and shade that much of this graph. All right, and there you have it. It's this triangular area here. All right, I'm going to let you guys go ahead and do the rest of these, and it should be pretty straightforward. All right, thanks for watching.